the end of century. So we sort of compare those two precipitation. Those information provide, we can know the magnitude of the worst case, like what's the worst case of the rainfall. And then for the policy, we can sort of adjust the standard or threshold of like our infrastructure. And although there's some limitation because this is from the dynamic downscaling, it's a single model, there's some uncertainty need to resolve. The second one is experiment called pseudo global warming historic typhoon event. Okay, so the basic concept is what if Typhoon Morak happens in the future in a warming scenario? So we sort of to figure out, okay, it's not just Typhoon Morak happens again, but happen in the future, in the end of the century, or we can see whether whether the magnitude of the typhoon will increase. And then we have some initial finding about in the flatland rainfall has increase and rainfall change rate increase. For the mountainous area, rainfall increase, but the rainfall change rate increase, but not so much. It's because the mountainous area has already, the rainfall of the mountainous area is already very high. So these two study is used to, so we can picture the extent or the magnitude of the extreme event in the future. And the third one is we sort of put it into the design impact assessment about in terms of river flow. We sort of use the model river flow simulation to know from the precipitation to river flow to see whether those river flow has increased in the near future and in the end of century. Using Zengwen River as an example, you can see like there's one Xinzhong water level station in the base line. The top 10 typhoon event, only one event exists is design flow. Near future, two events exist the design flow. The end of century, with 7 events exist the design flow. So those information can help to know the potential risk of flooding, especially the frequency of the overflooding. And so we can sort of design we can sort of adjust the policy. And okay, the fourth cases is we call it comprehensive river basin management under the extreme climate scenario. Also use the Zengwen River as an example. We see in Taiwan the river basin is actually the problem goes from the upstream. Upstream, we have some development or not development, but we have some settlement landslides will go off into the river. You will reduce the river flow, and we have some problem in the middle stream, the river strike, and we have the coast problem. The storm surge will go backward, so cause the problem in the cities. Cause the flooding problem. So we'll try to review the problem with a system. And we do the worst case scenario, we do a simulation in settlement simulation, flooding simulation, and coastal disaster simulation, put it together, and we put another system impact assessment. We try to see how the loss and the damage of this kind of disaster. So this is the system we developed in our in NCDR called Taiwan Typhoon Loss Assessment System, TLAS. We have 7 modules. We have affect household, land loss, so we know the land use, and also we have a variety of the social economic use like industry, etc. So we can see those kind of flooding and landslide might affect how many people, how many households, and we can so calculate the poverty lost. So this type of information can know the potential risk, the area, the flooding area, and the damage of flooding. And those policies can put into the comprehensive river basin management. So maybe we can put some retaining pool, retaining area in the upstream, and also or reduce the development in the upstream, etc. And it can also put into a land use policy to change maybe the difference of the land use pattern. The last one is climate-related disaster risk maps. So we have put those variables into risk map. We have the hazard, vulnerability, environmental and social vulnerability, and then we have available indicators to have those kind of map. It's flooding, coast flooding, and this is slope land disaster, and this is drought, especially for the public water usage. So we can know relatively which area has a higher risk. So this type of information can provide information in terms of impact instant and spatial distribution, like where is the hotspot, and whether those hotspots shift in the near future or in the end of century. And we can put into a policy, so we can use this variable, we can put something actually in the environmental and socio-economic vulnerability, like the population density or something, and then use policy, etc. The conclusion. So I believe like the collaboration between climate science, disaster risk assessment, and adaptive policy is an ongoing process, and it needs to be done like right now. And also with the increasing understanding of the climate change impacts, like if we provide more quantitative information with climate science models, disaster impact simulations, and we can sort of implement more sophisticated measures. And of course, there are so many things we can do in the future, like for the climate change impact adaptation assessment, we can sort of produce more quantitative data. And also we need to continue to improve the uncertainty of those assessments with more models in the dynamic downscaling scale. And also we need to conduct more science-based vulnerability and capacity assessment, and the adaptation policy assessment needs to be conducted, and it's quite difficult to sort of evaluate the efficiency, like the co-benefit trade-off sort of thing. And for the adaptation policy makers, those strategies should trace back to original risk of driving forces. And also the Ministry of Science and Technology actually is trying to initiate a co-project next year in Sustainable Science co-project is called Integrated Risk Governance Project Climate Change Disaster Risk. It tries to integrate multidisciplinary, multi-agency, and including civil society, and also put into some expert in social science area, and try to integrate those different kind of research community. And for climate scientists, risk analysis, and policy makers, I think translate scientific information accurately is very important. Last slide. I'm going to conclude with a picture of ET, because I think climate science community, design impact assessment community, adaptive policy community, or maybe with other concerned citizens, needs to connect, communicate, and sort of collaborate together, so we can put science into real practice. Okay. Thank you for your attention.
Okay, thank you. Nice talk. In fact, it's presenting the practical conversion from the climate science into the adaptation policy. So it's a good case. It's started. Okay, open for question. Any questions?
Excuse me, may I ask a question relevant to your background but not included in your slides? I would like to know, have you ever participated in the policy formulation process of the United States government when you studied in New Jersey? And if yes, how did this experience affect you and your research right now? And also, excuse me, if I may, I would like to ask Dr. Higgins and Ms. Nielsen. Um, if there is any opportunity to open to Taiwanese students if we study in the United States. Thank you very much.
Wow, I never would think I will be asked about question about the case in the United States. Okay, correct me for people from the States. I studied in the United States for 6 years in environmental policy, and we learn about those policy making process, right? So we sort of know like the science is very important, provide the scientific evidence, and we realize, especially for the democratic governance, like in the states and also in Taiwan, the stakeholders' involvement, the citizen participation is very important right now to sort of avoid or sort of reduce the conflicts of those some controversial and complex issues like climate change or some other environmental issues. So I think Taiwan is in the process of learning how to put those pieces together, how to put the science and how to put the public opinion. It's not just a formal process you need to go through. It's not just the public hearing you need to hear. It's just how to real integrate those public opinions sort of put into the policy. And I think that's the most important things. And we can learn from this United States, but I think the United States has different kind of spatial scale. I think in New Jersey, like in I think state governments probably play a more important role considered than the federal government in terms of environmental policy. Yeah, I don't know if I answer your questions.
Okay.
Yes.
Is that possible for Dr. Hagen to respond first?
Sure. So on behalf of EPA, we have internships through our programs, and for depending on your field of research, through our Office of Research and Development, you may also be eligible to work as an intern or through other educational or fellowship programs. And I think information about that is on the EPA website for students.
And similarly at NOAA, we have, in particular have several excellent postdoctoral programs. Global Change Research Fellows, for example, who want to work on the climate science side. But we also have Sea Grant, which actually has both science and policy. And there are actually a number of other programs. So it really depends on your field of study as to which program I would recommend. So maybe we could talk more.
My field of study is majorly the law of the sea and international relations. So I'm wondering,
Mention, but
thank you very much.
Okay. Any question, Dr. Wu?
I realize this may be up, but you look at down or statistical, the devil's in the details of how you do that. It's very easy to do analyses that get you the central values, but to do the wings of events is very difficult and really takes very careful tools. So I was just wondering what type of analysis is going on in your agency that the result will really I want.
Hello. Actually, you are right. I couldn't answer your question, but I can have my colleague to sort of email you later on. But one problem we face actually to present this presentation is the colleague, Dr. Chen was doing the dynamic downscaling everything. And he always warned us, like, you can't use the information. You can't interpret this way because there are still a lot need to solve. I think that's the tables you were mentioning. But I think for the policymaker point of view, we sort of need to use the best available science we can use right now. Like actually, you can see the adaptation policy has been doing anyway, but those policy are sort of fundamentally or basically strategy. So we try to sort of figure out whether we can have more quantitative information, even though we know there's uncertainty, especially because we only use one models. And we try to, I think maybe next stage of TCC, we try to use more models, try to figure out whether we can reduce the uncertainty of those information. But yeah, you were right there. Our colleague warned us that there's some devils in those information.
Okay, thanks. Any more questions? No? Okay. Probably I think we just stop here for this section for short break.